My fabulous chemistry minions, let's get into the prep for bonding to help us study for this test. Remember, if you don't remember from class, yes, it closes tomorrow, 11:19, 8 a.m. is when the quiz closes. And there is a new Castle quiz labeled Bonding Quiz 2 if you need it, because it will more match this particular prep. Perfect. Okay, ready? A sample has these characteristics. Melting point, 984 K. Super hot. It's hard, brittle, solid at room temperature. Poor conductor of heat and electricity as a solid. Good conductor of heat and electricity as a liquid or aqueous solution. So, right off the bat, I'm going to say it's not a metal because of this. Poor conductor of heat and electricity as a solid. A metal is good at that. Okay. And then radioactive element, we haven't studied anything about that, so I'm going to leave that out. This is really a question of, is it ionic or is it covalent? And this is a great time for me to be able to explain something like this. This word molecular means covalent. So is it ionic or is it covalent? And covalents are good conductors of electricity in aqueous solution. So the answer is ionic compounds, because I know the difference between an ionic and a covalent substance. So, boom, got it right. Moving on to the next one. Okay, maybe got to use the mouse after all. Here we go. Which formula represents one ionic and one molecular compound? So here it is again. Molecular means covalent. It's a code word. I know I said it in the video at least once, I hope. And now here we go. I said it twice on this video. Nitrogen and nitrogen is covalent, two nonmetals. Sulfur and oxygen, two nonmetals, so that's covalent. Cl2 is Cl to Cl, which is two nonmetals, so that's covalent. H to an S, nonmetal and a nonmetal, that's covalent. Ba to Cl, so that's a metal. Ba is on the far left. If you didn't know barium was a metal, I just looked it up. It's in group 2, so it's a metal. So this is ionic. And then N2O4, that is nonmetal with a nonmetal, that's covalent. NaOH, this is a metal with a polyatomic ion, so I could say that that is ionic. And then Ba with an SO4, again, a metal with a polyatomic ion, that's ionic, and it's actually both. They're both actually both, ionic and covalent. So back to the question, which one is ionic and covalent? That leaves me with question C. Notice, this is one of those questions where one of the answers does not belong. The other one, the first two and the last one, the compounds fall into the same categories. This is the only one where they fall into different categories. I'm going to submit. We're correct. We're moving on. I hate to go too fast, but at the same time, I don't want this to be a 45-minute video for your sake. Okay? So, compound KHSO4, there is an ionic bond between. So this is one of the tricks where I know when there's a polyatomic ion, the polyatomic ion is covalently bonded. And if I didn't know that HSO4 was a polyatomic ion, that's where I go to table E and look it up. And notice H, S, and O are all they're all nonmetals. So this polyatomic ion is covalently bonded. And then it's going to be ionically bonded to the metal. I'm going to have a negative here, and I'm going to have a positive here. So the bond that's ionic is between the K and the HSO4. So I need to find that. And the answer for between K and HSO4 is D. KH plus, I do have a plus and I do have a minus, but KH plus is not going to be real. And KHSO3 with O2. Ooh, I can find O2 minus on a polyatomic ion sheet. But SO3 is also a polyatomic ion, so I have multiple ions going on here, so that's why that wouldn't work. And then this is just an improper molecule. It's missing the O4, so that can't be right. So I need K plus and HSO4 minus. That is a tricky polyatomic ion that we might not be used to. If you're going to see that question on my test or on the Regents, I'm guessing you're going to see one with like CO3, SO4, something that is a little bit more common. And so that's where there's another trick in this, is that SO4 right here is a polyatomic ion, but you need to know that H plus on the K is the problem, because H and K and H plus are ionically bonded. So they aren't going to ionically bond to this. That's just not how it works. The metal bonds to the polyatomic ion. Okay. Next, a question. Which statement explains why CH4 is nonpolar? Well, let's draw it. C, 4 bonds, H on each side. It's nonpolar because it passes the symmetry test this way, and it passes the symmetry test this way. So that's what makes it nonpolar. Okay, so let's see. The bonds between the atoms of the molecule are polar. We learned that I can have polar bonds and then a nonpolar molecule. So there's nothing to do with the bonds. And then the bonds between the atoms are ionic. That's actually a false statement. They are not ionic because carbon and hydrogen are both nonmetals. Now we're getting into the shape. And shape goes along with molecule, which we want. And then we also know this, ready? SNAP. Symmetrical is nonpolar. So it's telling me, why is it nonpolar? I need to find the S, which is symmetrical, right there. It's nonpolar because it's symmetrical. And that SNAP just bought me a question. So here we go. SNAP, symmetrical is nonpolar. And check it, we got it right. All right, and we got rid of the first two because it has to do with bond polarity, not molecular polarity. Molecular polarity takes all of the bonds into consideration. N2, this is a guy we need to be able to learn how to draw him pretty quick. There he is. It says, what is the total number of pairs? So this is a tricky question. It's pairs. A pair of electrons is 2. And 2 electrons, we know, equals a bond. So I can rephrase this and say, how many bonds? Well, how many bonds are between the ends? 3. The second best answer to this, and the one that's a real tricky one, is 6. Because the same question could ask you, how many electrons are being shared? Then it's 2 per bond, 3 bonds, then the answer is 6. The answer would never be 1 or 2. Okay, so you just have to read very carefully about a question like that to make sure we get it right. And that has to do with the fact that it asks for pairs. Okay, what occurs is 2 atoms of fluorine combined? Well, combined means I'm making a molecule, or I'm bonding. So every time I bond, I know energy is released. So right off the bat, I can get rid of this and this because energy is not being absorbed. That's breaking bonds. And then which one says I formed a bond? Well, B says I formed a bond, energy is being released. That is right from the very first bell work of the unit about making bonds and overall energy. Why do we even bond? Okay, Lewis dots, they are definitely drawn a little bit differently here. Notice the 2 bonds in between are trying to represent a bond. It says, which is the Lewis dot for a molecule having a nonpolar covalent bond? So right off the bat, I got to cross this guy off because he's ionic. I see the brackets, he's ionic. Nonpolar, so now I have to do the electronegativity between Cl and H and S and Cl. I'm actually going to not go ahead and do that because I know the electronegativity difference between 2 Cls, which I believe is 3.4, oxygen is 3.4. Whatever the number is, when I subtract Cl from Cl's number, it's going to be the same number, which is going to get me to 0. That gets me to nonpolar covalent right away. The other ones are obviously polar. Okay, and I'm not even looking that one up. I could look those up and just do all those calculations. I saw a shortcut, so I'm taking it. An ionic bond can be formed when 1 or more electrons are. So by definition, for an ionic bond, they are transferred from metal to non-metal. This is all non-negotiable stuff. I always go from metal to non-metal. So right off the bat, I can say equally shared, unequally shared. These are covalents. So those are wrong. I have transferred and I have transferred. That's what I need. Oh, from the nucleus or from the valence shell. Yo, if anybody picks that the electrons came from the nucleus, then we got a problem. Electrons are in those valence shells. We've been hammering that home. This is valence shell chemistry till we get to the last unit of the year. So electrons exist in the shells, not in the nucleus. So there's the giveaway on that one. And it can be a distractor that's that absurd. Okay, and I hope at this point for you guys that is absurd. Okay, which Lewis dot diagram correctly represents the reactant containing nitrogen? So this is a tough question to put in this because we don't know yet reactants and products. But the key is this arrow. And so everything on this side is reactants. And everything on this side is products. So first we need to know that part. And then it says containing nitrogen. So the reactant containing nitrogen, that's this guy right here. And notice, they don't screw you up there. It's the N with the H's, so you know it's that. It is NH3. So right off the bat, I can cross off these two because these are both NH4. And we're not talking about NH4. Okay, and then this is old school, so you won't actually see this, I believe, on the exam because I taught you to draw this like this with the bonds. I did not teach you to draw it with the electrons there, but you can see that this particular one that's wrong, C, is missing 2 electrons if I were to do it their way, where here it has those electrons here that the hydrogen brought. Oops, I messed up on this one. So it's just an old school way of showing something that I taught you guys how to draw properly, like this. This one matches this closest, so we're going to take that one and run. Almost halfway done. Sorry, I know I'm doing my best to keep this going fast. I know that there's 20 problems. It takes forever. But I really do hope that this helps you guys understand, break down the questions, and get better and take the test and do better at the test. Which statement explains why Br2 is a liquid? This is an intermolecular forces question. Liquid is going to have weaker intermolecular forces than a solid. So both of these things are nonpolar because they're diatomics. I know all diatomics are nonpolar. So let me get rid of this and let me get rid of this. And now we're talking about intermolecular forces. A liquid's intermolecular force has got to be lower than a solid. A solid has to have a higher intermolecular force. So molecules of I2 have a stronger intermolecular force. That's why it's a solid. Makes sense. And we're off to the races. On to the second half of this. What is the maximum number of carbon? So when I draw carbon, 1, 2, 3, 4 bonds is what it can make. We've been working on that for a minute. The carbon hybridizes as electrons. So boom, that's a good question to have in there. 3 easy points if you ask me, because I've been paying attention. When combining with nonmetallic atoms, metal atoms generally boom. Well, metal, non-metal, that tells me ionic. And I know that ionics transfer electrons from metal to non-metal. We just wrote this on a different question. No, I know I wrote that exact thing on a different question because I know what ionics are, and that's the definition, and I didn't write it properly. It's metal to non-metal milks. I turned around and looked and looked, I forgot the non. So happens when you're going fast. From metal to non-metal, we know that this is there. So if metals are transferring electrons from metal to non-metal, are they gaining or losing? Well, they all have positive charges, so they are losing electrons. So I can cross off these two as they're gaining. And then metals, I look on a periodic table, they all form positive ions. When I lose an electron, I form a positive ion. So boom, here we go. Just another way of saying metals transfer electrons from metal to, or ionics transfer electrons from metal to non-metal. Just another way of stating the same thing. And we're off to the races. Which element forms an ionic compound when it reacts with lithium? Well, ionic means metal and non-metal. And when I look up lithium, lithium is a metal. So I'm looking for some sort of non-metal. I could restate this question as which of the following is a non-metal, but that would make life too easy. All right, because I need to know that an ionic bond forms between a metal and a non-metal. That's really what they're testing. And so K is a metal, Fe is a metal. I have two non-metals, and here's where life gets tricky. I have Br and Kr, and then when I look up, Kr is a noble gas. And we know from last unit, noble gases do not react. So it would form with a Br. LiBr is who would form an ionic compound. Breathe, Noakes, breathe. Doing good. Next one, 14. Almost 3/4 of the way there. The bond between which two atoms is most polar? All right, so now I just got to look it up. Table E or table S. Let me grab a reference table. This is unfortunately a look it up question, so you got to look it up. Don't mess around. Excuse me. Electronegativity of chlorine is 3.2. 3.2. Fluorine, 4, right? That's the only one I really know off the top of my head. So fluorine is 4. Fluorine is 4. And then bromine is 3.0. 3.0. So I got an answer here of 0.2, 1.0. And then iodine, electronegativity. So I'm looking for the electronegativity difference. Difference is subtract. Remember, it is an absolute value type of thing, 2.7 and 2.7. 2.7 to 3.2 is 0.5. And this is 1.3. So most polar is the highest number. Boom, he's number 1. And then BRF would be number 2. Okay, so here we go. And I got the right answer. And moving right on to the next one, number 15. What is the total number of electrons shared in a double covalent bond? So let me do oxygen, because I know that that's the most famous of my double bonded covalent molecules. It says the total number of electrons shared. Well, here's where I got to remember. There's 2 electrons in that bond and 2 electrons in this bond. So there are 4 total electrons being shared. Notice that this is a different kind of question than we did the other one that said pairs. I want to make sure both questions were there so we can understand and differentiate between the two. This one is easier. Pairs is tricky, so pairs, be careful, okay? Which formula represents a polar molecule? Polar molecule means it's not symmetrical. If you have to, you need to draw these. So there's HH, here's H2O, CO2. When you draw these enough, you can do these fast. CCl4. And I think it becomes very obvious, and we know that water is polar, and it is the only one that fails the symmetry test that way. So north and south, top and bottom are not the same. Water is my only polar molecule. And if you just remember off your top of your head that water is polar, then you can do that faster. But if you have to draw them all out, you have to draw them all out. I need you to be tenacious and not get that question wrong. Okay, hydrogen bonding, bell work from today. Hydrogen bonding is the strongest intermolecular force. Boom, definition question. Moving on. Strongest intermolecular force. Which one represents a non-polar molecule? Well, I just drew these out. Water is definitely polar. Okay, so I'm not drawing that again. HCl looks like this. It fails the symmetry test right there, so he's polar. NH3 looks like this. He fails the symmetry test this way. He's polar. That leaves me with CH4. He passes the symmetry test both sides. Up, left and right, yes. Up top and bottom, yes. He passes. CH4 is nonpolar. SNAP. Remember, SNAP comes into play. Symmetrical is nonpolar. Asymmetrical is polar. 3 of those were asymmetrical. 1 of them was not, or was symmetrical. All right, chemical bonding. Sodium phosphate is classified as, this is the trick, PO4. When I see a polyatomic ion, P and O4 is a covalent bond. And then it's got a charge of like -3, and that hooks up with three NAs, and this between here and here is the ionic bond. So when I see a polyatomic ion, I know that both covalent and ionics are present, not metallic. That's the trick right there. They tried to trick you right there. And that was in the notes twice, that when there's a polyatomic ion, both ionic and covalents are present. One more and we are done. I don't think I put this question on your test either. You can be mad at me if I did, but I don't think I did, because I would have never have taught you to draw it this way. This is an old school question. Correct for CO2. I taught you to draw CO2 like this. And remember, that is a dot dot and a dot dot if I do red, and if I do carbon in black and bring him a dot and him a dot and him a dot and him a dot, that's really what's going on, and those are where our loop-de-loops will be drawn. So which one of these has that exact thing going on? Carbon does not have a lone pair like this on it, so that's off. Here, carbon has lone pairs and single bonds, so that's off. Here, carbon has a lone pair. The only thing that changed between this one and this one is this one has X's and O's, which is more accurate, or this one has two just dots and this one has two X's, so that's not right. This one is the one that matches what the way I taught you how to draw it most closely. And so this is just for learning for things like the prep, and I don't believe you'll find anything like that on the quiz. So with that, we just went through all of the ionic bonding prep questions, and hopefully this helps you study for your test. And with that,